right, let's go ahead and take a look. I put the answers to those evens 2 through 12 up here, along with the 2 grouping problems, if you want to check to see how you did. Remember, in number 4, when you factored number 4, you ended up with still squares inside the parentheses. Remember, double check, especially when you did number 4, you could have factored that x squared minus 9 even further. So make sure you're factoring completely if you can. Any questions on these even problems, or 10 and 12 were specifically the ones that I was really referring to in terms of lots of different ways you could have been taught to factor a trinomial where the leading coefficient is not a 1. I know there's I think there's the n method. Is that still around? The n method, does that sound familiar to anybody? Box method, grouping, slide and divide. I don't know if you've heard of any of those, or there could be others out there. But I know there's lots of different ways you could have a guess and check for 10 and 12. There's lots of methods that are out there that you may have been taught to factor those. If you're, I personally use slide and divide. I know some math teachers slap hands and say, no, you can't use it. I don't know why they feel that way, but hey, whatever suits you. Questions on these that you'd like me to go over? Any questions on? So hopefully I've at least got some of the cobwebs and dust cleaned off upstairs a little bit to help us start thinking about factoring a little bit. Yes, Tony.
I'm sorry, can you go over 12?
Sure, number 12. So what I used here in number 12 was I used slide and divide. So in problem number 12, the original problem was 3x squared minus 13x plus 4. That was the original problem. So again, depending upon the method you're using, like I said, I use slide and divide. What I did was you multiply the 3 times the 4 together. So you multiply the constant and the leading coefficient together. So 3 times 4 is 12. I rewrite the trinomial, dropping the number in front of x squared and replacing the constant with 12. You should now have a trinomial that you can factor. So I can factor x squared minus 13x plus 12 into x minus 12 times x minus 1. You good so far? We call it slide and divide for a reason. You have to divide something, you have to slide something. So this original coefficient of x squared, that 3 that we dropped, this is where the dividing comes in. You take that 12 and you divide it by 3. You take that 1 and divide it by 3. So this is where the sliding comes in. We did the dividing, now we have to do the sliding. Reduce your fractions before you slide. So 12 divided by 3, that's where the 4 comes from. We don't factor with fractions. So we're going to take this denominator of 3 and we slide it to be the coefficient of x. Again, is it the best method out there? No, there's lots of other ways. I don't know if that's what you were taught or not. Slide and divide seems like it's a long process, but once you practice a few, it goes pretty quickly. For me anyway. Other people may use grouping, which is fine. It's a similar method to grouping, but how many of you have used slide and divide before, have heard of it? So a couple of you. Okay. So any other questions on those? All right, so what we're going to do now is we're going to do, since we did, when we start our trig, which we are going to start the unit on Monday, we're going to be working a lot with radicals. Again, making sure you're comfortable simplifying, rationalizing denominators. So now that we refreshed our memory on factoring, now what we're going to do is make sure we're comfortable in working with radicals. I know what you're thinking. I can read your mind. I'm kidding. Kidding, Paul. Oh, no, I didn't. Okay, shoot. I thought I was short. So like I said, with trig, when we start the trig component of the course, radicals are, we're going to be working with lots of radicals. So again, I want to make sure you're comfortable. I know some of you, I know you did some of this work in Algebra 2. But remember, when you simplify radicals, we always want to make sure they are in simplest form. And when I say that, that means there's no perfect squares in the radicand. The radicand is the number that's underneath the radical. And remember, when I say simplify radicals, you must also rationalize denominators. So when your fractions are also considered to be in simplest form, there should be no radicals in your denominator. If you have a binomial, so first of all, remember a binomial is when you have two terms separated by a plus or minus. Then the only way you can rationalize that denominator is to multiply the numerator and denominator by the conjugate. And this is something that was introduced to you last year in Algebra 2 in the virtual format, which is why I want to make sure I address this with you. Word conjugate, vaguely sound familiar a little bit? So just to review, the conjugate, when you look at your factors a plus b times a minus b, and when we reviewed factoring difference of squares on Monday, a plus b and a minus b, they are conjugates of one another. So what makes a conjugate of a binomial is when the sign between the two terms flip. So for example, the conjugate of 4 minus square root 3 is 4 plus square root 3. What's special about conjugates is when you FOIL a binomial and its conjugate together, what you're left with is you're left with just the a squared minus b squared. What happens when you FOIL a binomial and a conjugate, the outer and inner terms are going to cancel out because one would be a plus and one would be a minus. So that's how you eliminate that radical in the denominator if you have a binomial. Later on this year, we're not only going to be rationalizing denominators, you can also rationalize numerators, get rid of the radical in the numerator. And you do, to rationalize a numerator, it's exactly the same process as rationalizing a denominator. You multiply the numerator and the denominator. This case, you're going to multiply by whatever radicals in the numerator. So just like you can rationalize a denominator, you can rationalize a numerator. That'll come up later on. So now let's take a look at, we're going to bounce around. I'll do a couple examples and I'll give you some time to practice these on your own. So let's take a look at number 1, 3 divided by square root 6. So just a reminder, to rationalize the denominator, what you're going to do is you're going to multiply the numerator and the denominator by the radical in the denominator by square root 6. So when you multiply straight across, you end up with 3 square root 6. Now, when you multiply square root 6 times square root 6, that gives you the square root of 36, which is just 6. Questions on how to multiply the numerator and denominator by square root 6. At this level of math, I should never have to tell you, you will always simplify fractions. That is understood. You will always simplify your fractions. Notice that 3 and 6 that are outside the radical, the 3 over 6, you can divide out a 3, so you're left with square root of 6 over 2. So any questions on rationalizing a denominator? Now in number 2, there's more than one correct way to get rid of the radical in the denominator. So for number 2, the 2 in the denominator is not the problem. What is the problem? The issue is the square root of 3. So all you have to do is multiply the numerator and denominator by square root 3. If you did, however, multiply the numerator and denominator by 2 square root 3, you'd still end up with the same answer. Just what happens is you have more simplifying of your final answer. In other words, you're going to have to reduce the fraction a little bit more. All right, that's the only difference, but you can still end up with the same answer. So this would give me 3 square root 3 over, this is 2 times square root 9, which is just 2 times 3, which is 6. And then again, notice you can divide out that 3, so you end up with square root 3 over 2. So questions on number 2. Number 3, the square root of 5 over 7. Remember your quotient property of radicals. Anytime you have a fraction underneath of a radical, what you actually have is the square root of the numerator divided by the square root of the denominator. So anytime you have a fraction under the radical, you do have a square root in that denominator. You do have to rationalize it. That's your quotient property of radicals. Okay, questions on that? One more I'll do, and then you'll leave the rest for you to do. Let's take a look at problem number 7. So notice number 7 is an example where you've got a binomial in the denominator. It's different than all the others because notice you have the subtraction sign in the denominator. So this is where you have to multiply the numerator and denominator by the conjugate. The conjugate of 1 minus square root 3, you just change that subtraction sign into an addition sign. So I'm going to multiply the numerator and denominator by square root 1 plus square root 3. And I'm going to put parentheses around that. You don't have to distribute the 2 right now. Just leave it as 2 times 1 plus square root 3 in the numerator. If you did distribute, that's absolutely fine. Now, when you FOIL, and again, don't waste your time, ladies and gentlemen, all you're going to do is multiply the first and the last terms together, because remember with conjugates, those outers and inners are always going to cancel. So just multiply your first terms together. So 1 times 1 is 1. Multiply your last terms together. Negative square root 3 times square root 3 is going to give you a negative square root 9 or just a minus 3. Don't waste, unless you love foiling and you love multiplying, don't waste your time. Anytime you do a binomial conjugate, the outers and inners are always going to cancel. So just do the first and the last. So then again, simplify your fraction. Notice you've got a negative 2 now in the denominator. This is why I didn't want to distribute the 2 in the beginning, because you knew you were going to have to reduce this fraction in the end, perhaps. So this, I can divide out a negative 2, so I'm left with negative 1 plus square root 3. Or if you did distribute, that's absolutely fine. Either answer, I would accept either answer. If you leave it in factored form, that's fine. If you distribute, that's absolutely fine too. So any questions on that conjugate piece? So all of you now go ahead and finish up. There are 2 problems on the back, so go ahead and finish up the problems we didn't do and the 2 problems on the back.